Hello students, myself is Parminder Singh from Prab Kirpa classes. Our today's topic is measuring hemispheres, exploring surface area and volumes. After going through this course, the students will understand that hemisphere is only half of a sphere. They will also understand that what is the meaning of a sphere, and they will also understand what is the difference between sphere and a hemisphere. They will understand that while sphere has only one face, the hemisphere has two faces. One is curved face and another is flat face. The students will also understand that there are many real world examples of hemispheres. They will also understand that they can calculate the curved surface area of a hemisphere by the formula 2 pi r square. The students will also understand that how to calculate the total surface area of a hemisphere. The students will also understand that they can calculate the volume of a hemisphere by using the formula 2 over 3 pi r cube. They will also understand how the formula of volume of a sphere is related to the volume of a sphere. In this course, we will solve many questions pertaining to the surface area and volume of a sphere so that you can better understand this concept. Now we will understand what is hemisphere, what is the difference between hemisphere and sphere, what are the real world examples of hemisphere, and how we can calculate the curved surface area and total surface area of hemisphere. First of all, we will talk about hemisphere. Hemisphere is a term which is used in geometry to describe half of a sphere. If we have seen sphere, it looks like this. And if we take half of the sphere, each part is called hemisphere. In other words, we can say that sphere consists of two hemispheres. The word hemisphere is derived from the Greek words, and these words are hemi and sapphira. Hemi means half and sapphira means sphere. Hemisphere can be thought of as a half ball or a dome shaped structure. Now, what is the difference between hemisphere and sphere? A sphere is a three-dimensional geometric shape. You can see here that this is a sphere which is completely round, and all the points on it, whether we take it this or this or this, all the points are at equal distance from the center. That is, the distance from the outer side of the sphere to the central point is same. This one, all these are same. That is, the radius of the sphere is the same, with all the points on its surface equidistant from the center. That is, any point on the surface is at equal distance from the center of the sphere. A sphere has only one face and which is curved. Now we talk about what is hemisphere. A hemisphere is half of a sphere. A hemisphere has two faces. This is the curved face, this one. This is the curved face. And this one is flat face, or we also call it base. These two shapes, that is hemisphere and sphere, are related, but the hemisphere has a flat base while a sphere does not has base. Now, what are the real world examples of hemisphere? The dome of a building is generally hemispherical in shape. A satellite dish is hemispherical in shape. The earth can be divided into northern hemisphere and southern hemisphere. That is, earth can be divided into two hemispheres. A bubble is a hemispherical shape of liquid. Now, the surface area of hemisphere. The surface area of a sphere is 4 pi r square. First of all, we take the surface area of sphere, which is completely round, and its total surface area is 4 pi r square. This is sphere. And when we talk about the curved surface area, this is the curved surface area of the hemisphere. It means we are talking about this one, half side. And naturally, when we are talking about only half side of the sphere, that is the curved surface area. This is the curved surface area. Curved surface area of the hemisphere, it will be naturally half of the 4 pi r square. So, curved surface area of hemisphere is equal to half of surface area of sphere is equal to 2 pi r square. So, we have to use 2 pi r square when we are to calculate the curved surface area of hemisphere. Now we will talk about the total surface area of hemisphere. When we talk about the total surface area of the hemisphere, we not only include the curved surface area, this one, this is the curved surface area. We also include the area of base, this one. So we have already calculated that this is 2 pi r square curved surface area, and the area of base is pi r square. When we sum total the both, that is the curved surface area and area of base, we arrive at the total surface area of the base. In other words, we can say that in the case of total surface area, we include the curved surface area as well as the area of flat face or base. So this is 2 pi r square and this is pi r square, and we combine both and we arrive at 3 pi r square. Now the applications of hemisphere area in real world problems, that is where we use these formulas. Hemisphere surface area is used in many real world applications, such as to calculate the surface area of hemisphere shaped tank or container. Next is to determine the amount of material needed to coat a hemispherical surface such as a dome or a dome shaped structure. We will later on discuss the numerical examples where we will actually use these formulas to arrive at the curved surface area and total surface area of hemisphere. Now we are to find the curved surface area of a hemisphere with a radius of 6 centimeter. You know that the curved surface area of hemisphere is the area of the rounded surface, that is this part. We are to calculate the area of this part which is curved, which is in round shape. So answer, what is given to us is radius, it is 6 centimeter. What we are to calculate, we are to calculate curved surface area of hemisphere. We have already learnt that we can calculate the curved surface area of hemisphere by the formula 2 pi r square. So now we will put in the relevant values. We know that pi is a mathematical constant and which is represented by 22/7. Now we will put in the value of r square. R is 6, or then we will put 6 again. So now it becomes 2 multiplied by 6 multiplied by 6, 72 into 22/7, and if we solve it, we will arrive at 226.28 square centimeter. This is the curved surface area of hemisphere. This is the answer. Now the question before us is, find the total surface area of a hemisphere of radius 10 centimeter. The value of pi has been given as 3.14. We have already learnt that the surface area of this curved face, this one rounded face, can be calculated by the formula 2 pi r square, and the area of this flat face or flat face can be calculated by pi r square. And if we combine both, that is the curved surface area and the area of flat face, we arrive at the total surface area of hemisphere. It becomes 3 pi r square. This calculation has been shown to you so that you may remember the same forever and you need not cram the formula. So what has been given to us is radius is equal to r is equal to 10 centimeter. Now the next is value of pi. Pi is equal to 3.14. What we are to calculate? We are to calculate total surface area of a hemisphere. This calculation of formula has been only shown to you for the purpose of remembering. You need not draw this picture. You know that the total surface area of a hemisphere can be calculated by the formula 3 pi r square. So now we will substitute the values. What is the value of pi? It is 3.14. What is the value of r? It is 10. Here r square is written, so we will multiply it by r again. So what is now? This will become 9.42 into 100. Now it will become 942 because 942/100 into 100. This will cut and ultimately the answer will be 942 square centimeter. So the total surface area of hemisphere is equal to 942 square centimeter. This is the answer. Now the question before us is, a hemispherical bowl made of brass has inner diameter of 10.5 centimeter. Find the cost of tin plating it on the inside at the rate of rupees 16 per 100 square centimeter. Here what we are to do? Here we are to tin plate. Tin plate means this side. We are to do tin plating. We are to tin plate the inside of hemispherical bowl. That is, we are to tin plate the inner side of the hemispherical bowl. So we have to calculate or find out inner curved surface area. What we have written? That we are to do tin plating on the inside of the hemisphere. This side we have to, all this have to be tin plated. So we have to calculate the curved surface area of the inner side. So what has been given to us is, given is inner diameter. Inner diameter. It is 10.5 centimeter. So we know that the radius is always half of diameter. It becomes 10.5 divided by 2. It becomes 5.25 centimeter. So what we have calculated? We have calculated radius from diameter. So now we will calculate the inner surface area of the bowl. This one, this side, inner surface area. Because we are to tin plate the inner surface area of the bowl. So how we can calculate the inner surface area of the bowl? The inner surface area of the bowl is equal to inner curved surface area. How we can calculate the inner curved surface area? We know that the formula for calculation of the same, this one, round surface, we use 2 pi r square. We will here feed the relevant values. What is the value of pi? It is 22/7. What is the value of r? It is 5.25. So we have added all the values. So after solving all this, we will arrive at 173.25 square centimeter. This is the inner surface area which we have to tin plate. Now what we have to finally calculate? We have to calculate the cost of tin plating the inside of the hemispherical bowl, and the rate of the same has been given. So what is given is cost of tin plating. What is the rate? It is rupees 16 per 100 square centimeter. Cost of tin plating 100 square centimeter is equal to rupees 16. The cost of tin plating 1 square centimeter 16/100. Now the cost of tin plating, what we have to calculate? We have to calculate the cost of tin plating the whole of inside of the hemispherical bowl. Now the what is the inner curved surface area? It is 173.25. So we will write it here, square centimeter. 16 over 100, 173.25. Now what we will arrive at? Now we will solve it. Point 2, 5, 7, 75. So, but we have 4, this will be deducted this will be divided by this, 4 into 6.93. Now we will multiply it. $27.72. This is rupees 27.72 paise. This is the cost of tin plating the inner side of the hemispherical bowl. Now the question before us is, a hemispherical bowl is made of steel 0.25 centimeter thick. The inner radius of the bowl is 5 centimeter. Find the outer curved surface area of the bowl. Now what is given to us? We have been given inner radius of bowl. What is the same? It is 5 centimeter. That is inner radius from this point to this point has been given. So now what is 0.25 centimeter? This is the this part. This is 5 and this part is 0.25. So now what we have to next find out? We have to find out the outer radius, because we have to finally calculate the outer curved surface area, and the outer curved surface area can be calculated only with the help of outer radius. So the outer radius of bowl is equal to inner radius plus thickness of bowl. What is inner radius? It is 5 centimeter. What is the thickness? 0.25 centimeter. So now what is the outer radius? It is 5.25 centimeter. So far we have calculated only the outer radius. So now what is the outer curved surface area of bowl? We know that the curved surface area of the bowl can be calculated by the formula 2 pi r square. This is the round shape and we have to calculate this area. 2 pi r square. Now we have to use here outer radius, because we have to calculate outer curved surface area. So the radius of the this point to this point, outer point, will be taken into consideration. we will fill in the relevant values. In case of pi, we will substitute it by 22/7. Now what is the radius? It is the outer radius. 5.25, 5.25. So now what will be before us, and we will ultimately arrive at, when we solve it, 173.25 square centimeter. Here what we have done, we were given inner radius and the thickness of the bow. From that we calculated the outer radius, and after arriving at the outer radius, we use the formula 2 pi r square to calculate the outer curved surface area of the bowl. Now the topic is volume of hemisphere. Firstly, we will understand what is the formula to calculate volume of hemisphere. It will be followed by numerical example. To derive the formula for the volume of a hemisphere, we can start with the formula for the volume of a sphere. The volume of a sphere can be calculated with the help of formula 4/3 pi r cube. This is the volume of a sphere, where r stands for radius. You know that the hemisphere is only half of the sphere. The volume of a hemisphere is also half of the volume of a sphere. So the volume of a hemisphere is 1/2 into 4/3 pi r cube. So we will arrive at 2/3 pi r cube. So this is the formula to calculate the volume of hemisphere. Now the question before us is, find the volume of a hemisphere with a radius of 6 centimeter. Now what is given? We have been given radius of hemisphere, r is equal to 6 centimeter. What we are to calculate? We are to calculate volume of a hemisphere. We know that what is the formula to calculate the volume of hemisphere? It is 2/3 pi r cube. Now we will fill in the relevant values. 2/3, pi stands for 22/7. Now we will fill the value of r cube. So we will write 6 into 6 into 6, and if we solve it, we will arrive at 452.57 cubic centimeter. So this is the volume of hemisphere. This is the answer before you. Thanks for watching. Now the question before us is, a hemispherical bowl has a diameter of 7 centimeter. What would be the volume of water it would contain? What has been given to us? We have been given diameter of hemispherical bowl. This is the hemispherical bowl, and from this point to this point, this is diameter. This is 7 centimeter. For the purpose of calculation of volume, we will have to calculate the value of r. R means from the center point to this point. This is r, and it will be the half of diameter, and it will be 3.5 centimeter. Now what we have to calculate ultimately is volume of water the hemispherical bowl would contain. If we put water into the hemispherical bowl, the volume of the water it will contain will be equal to the volume of the hemisphere. So now we will calculate this question, answer this question. What we have been given? We have been given diameter. This is 7 centimeter. We know that radius is half of diameter. So radius is 7/2. It is 3.5 centimeter. Now the volume of water hemispherical bowl would contain is equal to volume of hemisphere or hemispherical bowl. Now what is the formula to calculate the volume of hemisphere? It is 2/3 pi r cube. So we will fill in the relevant values. 2/3, what is the value of pi? It is 22/7. It is a mathematical constant. Now we will put in the value of 3.5. We have put in the value of r. It is 3.5. And if we solve all this, we will arrive at 89.8 cubic centimeter. So now this is the answer. Volume of water is equal to 89.8 cubic centimeter. Now the question before us is, how many liters of milk can a hemispherical bowl of diameter 10.5 centimeter hold? This is the hemispherical bowl. What has been given? We have been given diameter from this point to this point. What is this? It is 10.5 centimeter. Now what has been written? How many liters of milk the hemispherical bowl can hold? If we put milk into it, it can hold as much quantity of milk which will be equal to its volume. In other words, when we put milk into it, the quantity of the milk it can hold will be equal to the volume of the hemispherical bowl. So this is the diameter. For the purpose of calculation of volume, we take half of diameter. That is, we will calculate radius. Radius is half of diameter. What is given? Diameter is equal to 10.5 centimeter. So radius is 10.5/2 because radius is half of diameter. It will come as 5.25 centimeter. Now what we are to calculate? Quantity of milk a hemispherical bowl can hold. This is we have to calculate. It will be equal to the volume of hemispherical bowl or hemisphere. Now, what is the formula to calculate the volume of hemisphere? It is 2 over 3 pi r cube. Now we will fill in the values. 2 over 3 pi means 22 over 7. Now we will put in the value of r cube. So we will multiply 5.25. It will happen 3 times. So when we solve it, we will arrive at 303.18 centimeter, cubic centimeter. Now what is the question? How many liters of milk? Now what we have calculated, it is cubic centimeter. So we will have to convert it into cubic centimeter into liters. So we know that 1 cubic centimeter is equal to 1 milliliter, and 1 milliliter is equal to, we have to convert 1 milliliter into liters. You know that a liter, 1 liter contains 1000 milliliter. 1000 milliliter is equal to 1 liter. So 1 milliliter is equal to 1 over 1000 liter. So here it becomes 303.18 cubic centimeter is replaced by milliliter. So now we will convert this milliliter into liter. So what we will do, 303 over 1000. So what we will arrive at, 0.303 liter approximately. So this is the answer. Hemispherical bowl can hold milk is equal to 0.03 liters approximately. Now the question before us is, a hemispherical tank is made up of iron sheet 1 centimeter thick. If the inner radius is 1 meter, then the volume of the iron used to make the tank. What has been given to us is this inner radius from this point to this point. This has been given as 1 meter. Another point which has been given is thickness of iron sheet. This thickness, it is 1 centimeter. So now we will here solve the question. What has been given to us is inner radius. Inner radius has been given as 1 meter. But another thing has been given, it has been given as thickness of iron. Thickness is 1 centimeter. Now firstly we will calculate the outer radius. Outer radius is equal to inner radius plus thickness of iron. This is 1 meter plus 1 centimeter. We will convert it 1 centimeter into meters by dividing it by 100. So 1 meter plus 0.01 meter. It will come as 1.01 0.01 meter. So now what we have to calculate? We have to calculate the volume of iron used. We have to calculate this volume of iron used. This can be calculated by arriving at the volume of outer hemisphere and the volume of inner hemisphere. We will deduct the volume of inner hemisphere from the volume of the outer hemisphere. So volume of iron used is equal to volume of outer hemisphere minus volume of inner hemisphere. We will take the inner radius as small r. Here we will write it in capital letters, outer radius r. Now we will put in the relevant values, or we will use the relevant formula to calculate the volume of outer hemisphere. It is 2 over 3 pi r cube. Now here we will use outer radius. So r will be in capital letters. Now what is the volume of inner hemisphere? It is 2 over 3 pi r. R is small. In small letters, it is inner radius. So now we will put in the values 2 over 3. Pi stands for 22 over 7. What is r cube? R cube, r is in capital letter, it is 1.01. 1.01 cube minus what is the volume of inner hemisphere? We will put in here the relevant values. 2 over 3 pi 22 over 7. What is the value of r? It is 1. So what we arrive at is 2 over 3 into 22 over 7. Because here both these items are same, we will take it outside. So now what we are left with is this 1.01 cube minus 1 cube. So 2 over 3 into 22 over 7 into, after solving this 1.01 cube, we will arrive at 1.030, and when we solve 1 cube it becomes 1. So 2 over 3 into 22 over 7 into 0.030. So when we solve all this, we will arrive at 0.06 cubic meters. This is the answer before us. Volume of iron used is equal to 0.06 cubic meters. Now the question before us is, a dome of a building is in the form of a hemisphere. This is the dome and it is in the form of a hemisphere. From inside it was whitewashed at the cost of rupees 4,989.60 paise. If the cost of whitewashing is rupees 20 per square meter, find the inner surface area of the dome and the volume of the air inside the dome. So now what has been given? We have been given the total cost of whitewashing. Total cost of whitewashing is equal to rupees 4,989.60 paise. Next, another thing which has been given is cost of whitewashing per square meter. Per square meter. It is rupees 20. Now, when the total cost of whitewashing and the rate of whitewashing is given, we can arrive at the area which has been whitewashed, area whitewashed. It can be arrived at by dividing the total cost with the cost per square meter. So 4989.60 divided by 20. It will become 249.48 square meter. This is the area whitewashed. Now this is the area which has been whitewashed. Area whitewashed is the curved surface area of hemisphere. Because this dome is in the form of a hemisphere. So area whitewashed from the inside of the hemisphere is equal to the curved surface area of the hemisphere. So inner surface area of dome is equal to 249.48 square meter. This is the first answer. Inside surface area of the dome is equal to 249.48 square meter. So now the next is we have to calculate volume of the air inside the dome. Now the volume of the air which will be inside the dome will be equal to the volume of the dome, and the formula for the same is 2 over 3 pi r cube. So we will have to calculate radius. So now what has been given to us, we have calculated so far is the curved surface area. So curved surface area is equal to 249.48 square meter. We also know that the curved surface area of a hemisphere can be calculated by using the formula 2 pi r cube, 2 pi r square. So now it is equal to 249.48 square meter. So now we will put in the relevant values. Pi stands for 22 over 7. R is not known to us. So now r square is equal to 249.48 into 7 over 2 into 22, and it will come as 39.69. This is r square. So now r is equal to under root 39.69, and it will come as 6.3 meter. This is the value of r, radius. So now what we have to calculate? We have to calculate volume of air inside the dome. This we have to calculate. It is equal to the volume of hemisphere. What is the volume of the hemisphere? Only that amount of volume of air can be present inside the dome. So 2 over 3, we will put in the formula for calculation of volume of hemisphere. It is 2 over 3 pi r cube. 2 over 3, pi stands for 22 over 7. Now what is the value of r? It is 6.3. We will use this for 3 times. So now it will come as 523.90 cubic meter approximately. This is the answer volume of the air inside the dome. So now we will like to conclude this course. A hemisphere is a term which is used in geometry to describe half of a sphere. A sphere has only one face, that is curved, whereas a hemisphere has two faces. One is curved face and the another is flat face or base. Curved surface area of a hemisphere is equal to 2 pi r square, whereas the total surface area of the hemisphere is 3 pi r square, and the volume of a hemisphere is half of the volume of sphere, and it can be calculated by 2 over 3 pi r cube. Thanks for watching. If you like our course, please spare some time to give star rating to our course.